As a leading tourist destination in Indonesia, Bali has been recognized for its natural beauty and diversity in culture by the world. It also caused by the strong philosophy of life owned by Balinese people. They believe that the principle of Trihita Karana must be preserved and practiced in order to keep the balance of life. Trihita Karana itself means the three causes of prosperity. Tri means tree, Hita means prosperity, Karana means causes. This principle is originated from the harmonious relationship between humans and their god or parahyangan, humans and environment or palemahan, and the relationship between humans and each other or pawongan. Based on this principle, we believe that people's attention to the environment is not a thing that can be ruled out. Bali is a relatively small island and one damage to the supporting ecosystem could impact the island greatly. As one of the most important ecosystems in Bali, mangrove forest stands in the front line preventing disasters caused by abrasion and tsunami. It is a type of forest that grows in tidal areas where the plants living in this area have a very high tolerance with the salt water. Mangrove forest is considered as the natural resources of the coastal area that has the function of protecting, preserving nature, and production. It has a very unique feature since it is connecting the land and ocean ecosystems. In fact, it can absorb carbon 5 times more than the usual forest inland, and it plays a very important role in controlling the climate change. Based on the result of the 2021 National Mangrove Map updating, the area of mangrove forest in Bali Province is approximately 2,144.8 hectares, spread over several locations like Lungkung, 217.46 hectares, Badung, 572.23 hectares, Denpasar, 518.5 hectares, Jembrana, 434 hectares, and Buleleng, 403.7 hectares. Most of the mangrove forests in Bali are in prime condition, with most of them having a dense canopy cover of 1,955.42 hectares, or about 91.2% of the total area, while the rest have a medium canopy cover of 114.7 hectares, or approximately 5.3% of the total area, and sparse canopy cover of 74.66 hectares, or about 3.5% of the total area. Most of the mangrove forests in Bali Province are located within the forest area managed by the state, which is approximately 1,593.82 hectares, or about 74.3% of the total area, and the rest is non-forest area, which is 550.98 hectares, or about 25.7% of the total area. In order to preserve the existence of mangrove forests in Bali, knowing the species of mangrove plant that builds the forest is highly important. Without proper identification, preservation efforts could not be carried out effectively and efficiently. The species of mangrove in Bali that can be found as the main components that build the mangrove ecosystems are Avicennia alba, Avicennia marina, Bruguera gymnorrhiza, Bruguera cylindrica, Cereops tagal, Cereops australis, Cereops zipeliana, Rhizopora mucronata, Rhizopora stylosa, Rhizopora apiculata, Rhizopora lamarckii, Soneratia alba, Soneratia caseolaris, Silocarpus granatum, Silocarpus molucensis, and Nipah fruticans. Naturally, each species of mangrove will grow in different area of the forest. It happens because each species needs different environment to be able to grow. The forest itself is divided into two zones. The outermost zone, which meets directly with the sea, and the deepest zone, which is side with the land. To make it easier in identifying these species, we can group them in the same family, the Avicenniaceae, Rhizoporaceae, Soneratiaceae, Meliaceae, and Palmae families. Avicennia alba and Avicennia marina are members of the Avicenniaceae family, which become the main components of Bali's mangrove forest. The special characteristics of this family are the fruit, which resembles a nut, and the root, which shaped like pencil. Avicennia alba. This species has a natural habitat and can grow massively in muddy soil and riverbanks. They are also very tolerant of high salinity. They can grow to 15 meters with a pencil-like fruit root, and the leaves are single-type with elliptical shape, or some of them are scalpel-like shape. The leaves of Avicennia alba are long and slender, unlike the leaves of Avicennia marina. The types flowers of this species are inflorescences in the form of bunches, and there are 10 to 30 flowers in one bunch that could be found at the tips or armpits of the leaves. The color of the flowers are yellow to orange. The fruit of this species shapes like chili or cashew nut. The seed type is cryptoviviparian, which means that the seed germinates when the skin of the fruit is still covering the seed while it is attached to the parent tree. This species is also categorized as a pioneer species. Avicennia marina. This species looks very similar to Avicennia alba, but we could identify them from their special characteristics. The leaves of Avicennia marina are wider than Avicennia alba, and the amount of flowers in the bunches are lesser, only around 8 to 15 flowers in a bunch. In addition, the shape of the fruit is more like a nut. Avicennia marina is also a pioneer type with a cryptoviviparian seed type. The next family of mangrove species is Rhizoporaceae, which has a special characteristics where the fruit is cylindrical in shape and it is viviparous type, or commonly referred to as a propagules. The species in this family include Bruguera cylindrica, Bruguera gymnorrhiza, Cereops tagal, Cereops australis, Cereops zipeliana, Rhizopora lamarckii, Rhizopora stylosa, Rhizopora apiculata, and Rhizopora mucronata. Bruguera cylindrica. Bruguera cylindrica can grow up to 6 meters, has knee roots and buttresses and elliptical leaves with pointed ends. The special characteristics of this species is their small flowers, and one bunch of flowers consists of 3 flowers founded in the axils of the leaves. The color of the flower is white, the petals are yellowish green with a total of 8 petals. The propagules are cylindrical and slightly curved. The seeds are viviparous, where the hypocotyl falls together with the petals. The characteristics of viviparian seed is that the seed has germinated and comes out of the fruit skin white, still attached to the parent tree, are commonly called propagules. Propagules in this type are released from under the neck of the cotyledon and float and then dispersed with the help of water flow. Bruguera gymnorrhiza. Bruguera gymnorrhiza can grow up to 20 meters. The characteristics that distinguish this species from Bruguera cylindrica is larger flowers, single type, and red petals. The propagules are elliptical in shape and the color is dark green to purple with brown patches. Cereops tagal. This species can grow up to 6 meters. It has buttresses like the root of the tap and sometimes from a protruding knee root or breadroot. The leaves are dark green and single type with a reverse oval shape. The flowers are located in the axils of the leaves. Inflorescence type with a number of 5 to 10 flowers in one compound. The color of the flower crown is white and brown with green petals. The flower stem of this species is relatively longer than other species of Cereops. Propagules of these types are cylindrical, grooved, and nodule on the surface. The propagules are hanging and it is relatively longer with yellow cotyledon neck when the fruit is ripe. Cereops australis. This species can be found in West Bali area named Pecarakan. It has similar characteristics with Cereop tagal, but several distinguished features make this species different with Cereop tagal. The leaves of this species are shorter and more yellow to green in color. The flowers are longer, the petals and crown are longer and pointed, the propagules are shorter and smoother with no grooves and nodules. Cereops zipeliana. This species is mostly found in the Budang area, Jembrana Regency. Its special characteristics that distinguish it from other Cereops family are that they only have fewer flowers. Only 3 to 6 flowers in one inflorescence. The petals are hairless, and the propagules are slender and striated with pointy ends. If you look closely at the leaves, Cereops zipeliana has more lateral leaf bones around 11 to 12 pairs. Rhizophora lamarckii. Rhizophora lamarckii is a unique species and cannot be found in the large numbers. This species is the result of a crossbreeding between Rhizophora stylosa and Rhizophora apiculata. In general, this species has many similarities with their parents. However, the appearance of the flowers give a very visible difference. This species had 4 flowers arranged in twos on one stem. The stem is longer and the flower has 4 petals and a crown with reddish-green color. This species is generally sterile and never produce fruit and seeds. Rhizophora stylosa. This species can grow up to 6 meters, has a root that forming into branches, which makes it different from other Rhizophora species. The leaves are single and elliptical in shape with a yellowish-green color in the underside of the leaves and small black spots. It has compound flowers with a tube from of 8 to 16 flowers and a white ground. The propagules are cylindrical in shape with a diameter of 1.5 until 2 cm and a length of more than 30 cm. It has a green to yellowish-green hypocotyl and a greenish-yellow neck when ripe. The size of the hypocotyl is smaller than that of other Rhizophora species. This species is found down the edge of the sea and easily adapts to low slopes. Rhizophora apiculata. Rhizophora apiculata can grow up to 15 meters. It has smaller leaves than other Rhizophora species and the stipules are red. This species only has 2 flowers in one flower stalk. Another distinguishing feature is the red color of neck of the cotyledons when the propagules is ripened. Rhizophora mucronata. This species has many similar characteristics with its relative Rhizophora stylosa, but there are some basic differences. It can reach 25 meters in height, the leaves are larger, fewer flowers in inflorescences, only 4 to 8 flowers in a bunch and hairy flower crown. Propagules of this species are also larger than Rhizophora stylosa. The next family species that builds up mangrove forest in Bali is Soneratiaceae. These species have special characteristics where the fruit is round and the breeding root is shaped like a cone. The species in this family are Soneratia alba and Soneratia caseolaris. Soneratia alba. This species can grow up to 16 meters, has a cone-shaped respiratory root, single leaf with oblong to oval shape and almost the same leaf surface on the top and bottom. The characteristic that distinguishes this type from the other is the white flower crown. Flowers of this type have many stamens and contain a lot of nectar. The petals are 6 to 8 strands and are a day flower or ephemeral, which means it blooms late at night and lasts all night. The fruit is round in shape with a cup-like decoration that comes from flower petals. The fruit is green and contains 150 until 200 seeds in one fruit. This species can grow in sandy mud at river mouths. It's often found in coastal areas, jutting into the sea and has a relatively high salinity. Soneratia caseolaris. In contrast to its relatives, Soneratia alba, this species can only thrive on the edge of river mouths which have low salinity with a mixture of fresh water. In general, the physical appearance of this species is almost the same as that of Soneratia alba, but there are fundamental differences, namely that the major flowers of this species have a red crown. The height of the bread roots can be more than 1 meter. The fruit is larger and in one fruit contains 800 until 1,200 seeds. The fruit of this type can also be eaten. In the Meliaceae family, there are 2 species which is often found in mangrove forests in Bali, Psilocarpus granatum and Psilocarpus moluccensis. Psilocarpus granatum. This species can grow up to 8 meters, has patrices and plank roots. The leaves are compound and shaped like an ellipse to reverse oval. It has 3 bark that peels off randomly, and the patrices and roots are shaped like wavy snakes. Flowers of this species are compound type with panicle-shaped inflorescences, and one inflorescence contains 8 to 20 flowers. The crown is greenish-white with yellowish-green petals. The fruit is large, round like a melon with hard skin and yellowish-brown in color. Weighing between 1 until 2 kg, and there are 6 to 16 seeds in one fruit. Psilocarpus moluccensis. Comparing to its relative Psilocarpus granatum, this species has a big-shaped fruit root and more than 10 until 35 flowers in one flower stem. In addition, the fruit on this type is smaller than Psilocarpus granatum with smooth surface, green color, and has 4 until 10 seeds in one fruit. The last one is the Palmae family, and within the Bali mangrove forest, there is only one species could be found, Nipa fruticans. Its special characteristic is that the trunk of this tree is buried in the ground. The part of the tree that is often visible on the surface is the upper branches such as leaves and fruit. This type of tree is commonly referred to as the scout type. This species can grow up to 4 until 9 meters and has leaves with a lanceolate shape like a coconut. The flowers are brick red to yellowish, and the size of the flower could reach to 25 centimeters. The fruit of this species is round with a diameter of up to 45 centimeters and shaped almost like a pendant fruit. This species usually grows close together and forms pure commodities along river banks. All of the species above are the main components that builds up the mangrove forest, and it is only part of the diversity of mangrove species in Bali. As mentioned earlier, one form of practice of Trihita Karana is palamahan, which main purpose is maintaining the environmental balance, so the concept it is fitting for our effort to preserve the mangroves. As one of the deputies of the Ministry of Environment and Forestry, BPDAS Unda Anyar has made various efforts to conserve mangroves in Bali, such as rehabilitating damaged mangrove ecosystems. However, it should also be remembered that these efforts are the responsibility of all parties, both the government and the community. Saving mangrove means saving our lives. Save mangrove, save earth, save our life.